Okay, everybody. So we were discussing. We discussed the lab. If you watch the video, so we did the couple of online tasks. There were two mathematical tasks. One of the tasks was permutation. It's under the task 2, part 1. So if you see, this is basically the data, and we need to actually apply permutation using this particular pattern. Permutation is nothing. Permutation is basically permute, like you can say rearrange the bits according to this particular pattern. So now in order to permute this particular input according to this, how we can do that, it's very simple. And what you have to do is just put the numbering on the top of this. Let's say 1 2 3 4 5 6 7 8 9 and 10. So we have 10 bits, so we need to rearrange these 10 bits according to this pattern. So what does it mean? It means the bit at third position will come down here. Bit at third position is 0. Bit at 5 position will come down here, which is 1. Bit at second position, which is 0, it will come down here. 7. Bit at fourth position, it's 1. Bit at 10 position is 1. Bit at first position is 1. 9, 1, 8, 1, 6, 1. So this is basically how we actually apply permutation, and that's the result of permutation. Okay, so please make sure you actually did it the right way. Okay, so permutation, what is permutation? We just rearrange the bits according to this pattern. So that's what we call permutation. Next is the Diffi-Hellman algorithm, which is secret key exchange algorithm. And Diffi-Hellman is basically about how two entities can securely exchange the private key. Maybe, for example, if I'm the certificate authority, how I can issue you a certificate, maybe, or you can say how I can actually issue you a private key, public key, and all that kind of stuff. So we still use Diffi-Hellman to issue, or you can say to exchange the private keys between server and the user. So for example, let's understand the Diffi-Hellman using this particular example, and then you can use this example and you can get your lab done as well. And please bring the question in online session. So for example, we have two users or two people. Let's say we have one user is Alice and second is, for example, Bob. So we have two people, Alice and Bob, and let's say Alice has a private key, a private number, or a private key. You can say private key or private number. For example, it is 5. Then Bob has a private key. So Bob's private key is, for example, 4. And then they have a pre-shared, you can say a common pre-shared generator. And that is basically 6 mod 13. Okay. In your case, I think it's 3 mod 17 or something like that. So Bob has the same 6 mod 13. Since they are the legitimate user, so before they start communication, so we will actually give them this particular generator. Now the first thing is that there are two main steps how Bob can actually, or Alice can securely exchange the data. Firstly, the first step is step 1. Step 1 is calculate public values which they can exchange. Next is the step 2, which is calculate a shared secret which they will not share with anybody else. So in order to calculate the public value, how the step 1, how we can calculate that. So relationship is, they will use the common relationship 6 mod 13. Raised to power 6 raised to power their Alice private secret is 5. If you see, this is 5 goes down here, and Bob will do the same thing, 6 raised to power his private key mod 13. Now if you calculate 6 raised to power, it comes 776. You can use calculator for that, mod 13, and 6 raised to power is 1296 mod 13. Okay. Now, if you solve this relationship, you can use any calculator. Most of the scientific calculator comes with the button mod. You can use that, or you can use a Google calculator as well. So if you calculate this mod, like you need to put 7776 mod 13, the answer will come 2. you can calculate that. If you solve this equation, the answer will come 9. So now these are the public values. So what's going to happen? Alice, what she will do, she will actually send this public value to Bob. Bob will send his calculated value to Alice. So 2 will go down here and 9 will actually go to Alice. Now what will happen? Once Bob will receive this public value, Alice will receive the public value from Bob. Now what she will do, she will actually change the relationship. Like the base will be changed. Like instead of 6, now we will use the public value sent by Bob, like 9 mod 13. Again, raised to power the same secret, like Alice secret value, but we will change the base of the secret. Like instead of 6, it's gonna be 9. Bob will do the same thing, use Alice public key as a base of the shared secret 2 mod 13, raised to power again, same Bob's private key, which is 4. Same is the case with Alice. Now if we solve this, you will get the same secret value. You can actually calculate that. So this is the way how two people or two, you can say entities, they can actually share a common value by using Diffie-Hellman algorithm. So please bring up the questions. Please try to solve your lab assignment. If there is any question, please let me know. You need to repeat the same process. Thank you very much.